Armon Dadgar. Sorry, is there a bit of an echo on this thing? Let's stick it over here. And you'll find me all around the internet as just Armon. And I'm CTO and co-founder of HashiCorp. For those of you who are unfamiliar with the company, there's a decent likelihood you've probably played with Vagrant. As a company, we are really focused on sort of the entire process of delivering an application. So for us, we think about this in kind of 3 different layers. There's the sort of provisioning challenges of how do we get a development environment, how do we stand up sort of our staging environments, our production servers, and kind of provision the underlying storage, compute, and networking. Then sort of a distinct problem above that is how do we manage the security of all of our data? So database passwords, SSL certificates, API tokens, encryption of data. That's sort of the security challenges that we look at. And sort of the highest level is how do we run our applications, our databases, our queues, all of the sort of middleware necessary for our apps to work. And so there we have tools like Nomad, which is our application scheduler, and things like Console, which help kind of glue together all the machines in our cluster. So, a bit of just context in terms of, this is the space we work on, but I'm going to sort of zoom out and spend less time talking about tools, and sort of more time talking about DevOps and sort of the process itself of delivering an application. So, if we're going to spend some time talking about DevOps for startups, I think a useful place to start is by defining what DevOps is. I think one of the challenges when we talk about DevOps is, if you ask 5 people what it means, you're going to get 7 different answers. So it's going to range everything from, DevOps is you just have your developers do everything and you don't need operations people or security people. DevOps is you just get rid of operations and pretend you don't need to deal with it. It could be a cultural movement. The list sort of goes on in terms of how people talk about it. And not to say any of these is right or any of these is wrong, it's just sort of a very ambiguous term. So the way we like to think about it is sort of grounding it in the problem of delivering an application. So the way we think about a software organization is it's a system just like any other, right? And so it has components, it has inputs, it has outputs. And so when we think about this system, it's composed of people, it's composed of processes which organize how these people work together, and there's tools that support those processes. And so the output ultimately of the organization is applications, hopefully. So where this starts is with people, right? The nature of people is that they have specialized knowledge, right? We only know so much, we don't all know everything. And we have limited time, there's only 24 hours in the day. So we have our developers, and they have a certain set of expertise, right? They know some programming languages, they're maybe familiar with some frameworks, they know about application design patterns, so on and so forth. But that's not the only type of expertise we need to deliver an application, right? We need our operators who know things about, cloud APIs, system administration, networking, infrastructure. It's a different set of expertise. And then likewise, we have security teams who know about, threat modeling, they know about cryptography, they know about security patterns, which are different than, application patterns. And they care about things like compliance with various sort of laws. And so we have these different people in an organization who have different pieces of knowledge. And so, the mentality of, you only need developers and they can do everything, it works if you have unicorn developers, right? If you have these magical developers who know everything about networking and cloud and infrastructure and security and cryptography, then that could work, right? The challenge is there's just not a lot of unicorns in the world. So, if you can find them, maybe you can build an org just on unicorns. But for the rest of us, we need to hire folks and we need to work with teams that have different pieces of knowledge and make that work, right? And so the specialization of knowledge is real, and especially as your organization gets bigger, it's something you have to think about. And so one temptation is to simply outsource all of this, right? And say, well, if we're using the cloud, then we don't have to know anything about, operations. And to a degree, that's true. Some of it can be outsourced. You can leverage external services, but ultimately, how you're arranging, how you're consuming those resources still requires you to understand what's my security, how am I orchestrating in the cloud, how am I thinking about networking. All of the problems can't be outsourced. So we have these distinct people that are part of our organization. The next element becomes process, is how do we organize how they work together, right? right? If our developers, and our operators, and our security team have some subset of the knowledge, then we need some way for them to work together. And typically what we see is sort of the waterfall way of getting things done. It starts with our developers. They finish writing their code, they hand it off to the operator and say, okay, this needs to be packaged and go out to production. At the same time, they engage the security team and say, please check it and make sure I'm following best practice and that it's secure and so on and so forth. The operators then eventually do the same thing and say, did we set up SSH correctly? Did we set up the firewalls correctly? Are we in compliance? So on and so forth. And it sort of flows through the company in sort of a waterfall. And so if we're thinking about a software organization as a system, right, a very sort of important and interesting property is Amdahl's law. So it originally sort of comes out of the world of computing, which says that the theoretical throughput of your system is limited by its serial latency, right? So the number of things that have to be done in order, one at a time, limits the total output of the system. Which sort of makes sense, right? It's like if there is a serial process, that becomes the choke point. It becomes the bottleneck ultimately. And so if we think about our organization as just a system that's creating an application, it's really no different. The output in terms of delivering software is limited by the amount of coordination required to do so. And so how do we get around this? It really comes by removing that coordination. It's about enabling independence, right? So how do we enable individuals to work independently and improve the total throughput? So when we talk about delivering an application, there's a number of fundamental steps, right? What are all the things we have to think about and care about when we're designing a process to deliver an app? The way we think about it is there's 7 fundamentals. You have to write the application. You have to test it, hopefully. I mean, you can argue it's not necessary. You can package. So how do I compile to go to production? Whether I'm building a jar file, a Docker image, an Amazon AMI, there's sort of a packaging. Then I have to provision, so whether I'm using VMs in the cloud or Heroku, I still have to set up the Heroku app, I still have to set up the VM, I still have to set up Kubernetes, whatever I'm using. Then there's deployment, so how do we take the thing we packaged and compiled and basically push it onto the resources we've provisioned? Once it's out there, how do we monitor it to make sure things are up and running and healthy? And then lastly, how do we secure all of this, right? And this one, there's really no order to it. You kind of have to think about doing it at all of the steps. And so this sort of then culminates in how we think about DevOps, which is it is a process for doing each of these 7 steps in a way that optimizes for throughput as opposed to risk management, really. And so it's a focus on how do we reduce the coordination between these teams? How do we empower the individuals to work without talking to operations, talking to security, talking to QA? And it's really about how do we deliver apps faster? And so the way we do this is to use tools to coordinate between each of these steps instead of using people to coordinate the steps. So for us to get there, we need this clean separation of responsibility, right? If it's not clear what the developer does versus what the operator does versus what the security person does, it's hard to cleanly divide it. And so, going back to that first image I shared, this is sort of how we think about it when we're working with organizations, is how do you delineate into these 3 different sort of tiers and let them run separately? So we want our operators to be able to focus on the provisioning layer. They're providing the storage, compute, networking, the sort of core setup that the rest of the company is consuming. Then we have our security team, who is managing secrets, managing policy, and providing that as a service to the rest of the org. And then our developers live at the top tier, where they want to deploy an app, scale up and down, roll back, but they don't want to talk to the security people, nor do they want to talk to the operators. And so the goal is to move from that process where we went left to right to one where each of these teams is working in parallel, right? And so our developers, they really only care about some subset of the things that they, in that total step, they care about writing and testing, consuming secrets, deploying, but they don't really care about packaging, they don't really care about provisioning, they don't really care about security. And then our operators, same thing, they don't really care about writing and testing the code. They care about packaging, they care about provisioning infrastructure, they want to provide tools to the rest of the organization, and so on and so forth. Each team sort of wants to leverage their expertise and do it without sort of being in the way of everyone else. So is it just perfect, right? Is there silver bullets, right? And the answer is no, right? With great sort of power, if we're enabling all of these teams to just deploy whatever they want to production, there comes with that a responsibility. right? Developers have to become the owners of the application. So traditionally in the waterfall world, as a developer, when I hand it off to operations, it's not my problem anymore. I'm done. I wrote the code, I can check out for the day. It doesn't matter if it crashes, that's the operations team's problem. And so when you move to this other model where you say, as a developer, you can push whatever you want, you can scale up and down however you want, you can roll back whatever you want, it also means you own the app, right? You own its availability. And so this becomes, there's a need for more discipline and testing around how applications actually get built and deployed as a result of this, because it's not the monitoring team's problem or the ops team's problem anymore. So this does require investing in tooling. You have to enable everyone, you have to give them monitoring, you have to give them sort of the tools to run their app themselves, but you also have to educate them on what they need to do, how they do it. And so it's important to sort of ask your doctor if DevOps is right for you. Every process makes different assumptions, and the assumption that is being made with DevOps is that you care more about agility and the time to delivery than cost of a mistake, right? So what Waterfall is really protecting against is an error getting out into production. It's a risk management technique, right? Is you're sort of adding many manual checkpoints so that if there's a problem, you have many chances to catch it. On the flip side, with DevOps, there's really no opportunity. The developer can just do whatever they want, hit deploy, and there was no person who was sort of gating that out to production. So if there wasn't the discipline to test it and staging and make sure it works and do sort of a blue-green rollout, they could just blow up production with a click. And so it sort of depends on your risk tolerance, and it depends on sort of where you're at as an organization, whether it makes sense for you. And an interesting example I always like to use is avionics software. Like if you're writing sort of the autopilot for a plane, DevOps is probably the totally wrong model, right? The cost of a mistake is very high. People die. So you don't want to push, a new change 20 times a day and then roll back when something goes wrong, right? Like it's a really terrible model for building avionics software. Okay, so if that's our definition of DevOps, right? It's a process for delivering faster. It's a process for organizing specialized knowledge. Then how do we map this into startups? And in some sense, it's about scaling down DevOps, right? If what I talked about sounded very enterprisey, it's because it kind of is, right? Startups have many fewer people by nature. And so the impact of that is, the amount of specialization of knowledge is a lot lower. And so the process and the tools we use sort of need to reflect that. So typically, when we sort of talk about a startup anatomy, you don't usually have QA teams, you don't usually have security teams. If the company's small enough, you don't have operations teams. It's sort of a grab bag of developers with slightly different experiences, slightly different expertises, but you don't have these super focused teams. And so in the early days, you maybe just are a development team. And the constraints of a startup are also very different than the constraints of a large organization, right? A large organization typically isn't as cash flow constrained. Typically they are the incumbent, so it's not as much of a worry about racing against the clock. But with a startup, you have a burn, it's a race, it's a competitive market, and so you really want to focus on your core product, that minimum viable product, as much as possible. Everything else is just cost to the business. And so you want to outsource as much as possible. And as a startup, what's nice is we have a high risk tolerance, right? The default is failure, right? And so if the default is failure, embrace that risk and sort of, do the things that you can do in that environment that a large company can't. And so doing DevOps ends up being sort of natural for a small company because of the lack of specialization, right? If we go back to that chart of, if I have different people, how do I organize them? That sort of goes away if I only have developers, right? There doesn't need to be a flow between the developer, the operator, the security team. And so all developers are typically empowered to deploy in the early days, and there's sort of a shared set of tools, a shared set of understanding. And so the challenge really becomes, as you start specializing, as you start growing, how do you stay conscious of that and maintain that sort of aspect? So one element of it is really being pragmatic, right? Is as you're thinking about your infrastructure, as you're sort of designing it and bringing in specialized ops teams, build for the 1x case, right? Like don't build for the imaginary load of 10 billion users, right? Build for 1x, design your system to work for sort of 10x the number of users, right? So don't over-design for 1,000x growth, but plan ahead for 100x, right? So you're sort of thinking on the long term, if things go really well, is there a strategy to get out of this, or have we built ourselves into sort of a cul-de-sac? right? But then let's not actually build for the 100x because it's a bad use of our engineering time, right? It's like we all have to accept that we're not Google, and it'll take us more than a year or two to become Google. And the other thing is with startups, oftentimes the business and the product change along the way. So you don't want to make this massive investment in this hyper-scalable messaging architecture to then realize, actually, we're not a messaging company, we're going to go do something totally different. Like, we spent 2 years building this. So you want to stay flexible without building into the cul-de-sac. Okay, so if we're thinking about it in terms of these layers, what does that mean within each layer? So sort of just unpacking each one. As we think about the provisioning layer, just pick a cloud. Don't try and go down the bare metal route unless you have an extreme amount of expertise in that and you come from years of doing private data centers. It's a bad idea. There's large credits usually available to incentivize you to use some of the newer clouds. You can leverage the expertise of people that exist, right? A lot of people know how to work with the clouds. Not a lot of people know how to work in private data centers. And it's easy to spin up multiple environments, right? So as you start growing, you say, I want to have a staging environment and I want more development environments. That's a lot easier in the cloud versus in a bare metal world where it's like, great, now I have to go rack more hardware and there's this huge upfront investment. So adopting things like infrastructure as code early on in this process makes that really easy because you have this codified definition. So it's effectively a copy-paste to go from just production to production and staging. Right? You don't end up with this, oh, how did we actually set up production and let's reverse engineer the whole thing. As you start thinking about security, I think it's definitely the easiest one to skip as a startup. So really focus on the low-hanging fruit, the easy items, right? This is enabling two-factor authentication everywhere. This is building a simple network perimeter. So, actually have a private network that sits behind a firewall, only buying your load balancers to the public internet. It seems basic, but the number of vulnerabilities that are just like, an application with default passwords sitting on the public internet that gets compromised is shocking. And from the early days, try and avoid hard coding secrets and credentials into the applications, right? It's very easy for it to just get pasted in there and then people forget about it, and at some point that source code leaks or it gets out, and it's a very difficult problem to unwind, right? A small amount of prevention is worth a whole lot of cure. And then leverage things like external security monitoring, things like evident.io, because it makes it really easy to flag kind of these obvious security issues without you figuring it out because a customer told you or worse. And so then at the highest level, the sort of runtime layer where our developers are, is focus on developer productivity. That is the most important thing in the beginning. And so trying to overly focus on cost at the beginning is usually a mistake because the cost of your payroll is often much, much higher than the cost of your infrastructure. So until that flips, worrying about the infrastructure cost is sort of a mistake, right? So what you want to do is take that mentality of, assume I have 0 operators, how do I make my developers productive, right? And the answer is outsource as much as possible. Outsource your logging, outsource your metrics, outsource your monitoring, outsource your alerting, but don't build any of this stuff in-house because it's a waste of your time. And then leverage platforms as heavily as possible. Things like Amazon ECS, Nomad, Kubernetes, whatever. These are just going to make you more productive than building a lot of in-house tooling. So a quick note on that one is schedulers are fantastic, right? Like, grain of salt, we make one. But they're not silver bullets, right? They're complex pieces of software that have complex failure modes, right? They're many different moving pieces internally that interact in a very hard to understand way. And so when you're just starting up, keep it simple, right? Like, don't bring in all this massive complexity up front unless you really need it. The rule of thumb is you really need a dedicated operator or operations team to be able to really deal with this stuff, right? You don't want your developers to have to understand the complexity of all of it, and when something goes wrong, waste a bunch of development time to debug it. You want to be able to have an operations team that has some expertise and it understands it, knows how to make it, run in a performant way. And so sort of the question is asking yourselves, why do we actually need this, right? As opposed to something simpler. So then growing up, if we're starting small and saying, as a startup, we start with mostly developers, we don't have this, specialized knowledge base. How do we then grow up into doing DevOps in a larger setting? If all goes well, that's the plan, right? And so as you bring in more people, eventually you start needing to specialize the knowledge. Eventually you want operations teams, you want security teams, you want QA teams. And so it starts to look a lot more enterprising by nature. And so if done right, those extra people, that extra knowledge, allows you to get a lot more sophisticated in what you're doing, as opposed to sort of inevitably just becoming slow and terrible. So the first group that naturally comes in is usually a dedicated operations team. Right? At some point, the infrastructure is complex enough, there's enough developers, you say it's worth having a team that's just focused on providing the infrastructure to everyone else. And so usually they'll take on everything at once, right? Because it's like, oh great, it's the one team that's not development, so you inherit all of provisioning, security, runtime, the whole 9 yards. And so the short-term goals for the operations team should really be focusing on that developer productivity, especially given the small nature of a startup. So you want to provide a platform. So how do you make it easy to write code, to test it, to deploy, to monitor, enabling the developers basically, right? So it's going to be a ratio of 20 developers to 1 operator. You can't have everything bottleneck on the operator. And so you can start to evaluate fancier schedulers as you get to the size, right? As you have 1, 2, 3 operators, then you maybe have enough sort of internal bandwidth to start looking at these things. But really, the value comes from this richer tooling in terms of helping people to deploy, helping people to observe and understand what's happening with their application. Is there a load spike? Is it failing? Is there a high error rate? That tooling is super valuable. So observability, tracing, deployment tooling, that's super useful for developers. Then you start, the luxury of caring about performance comes a little later. Once you get a little bigger and you have more bandwidth and you sort of solve the lower level problems of tooling, then you can start caring about the performance. How do we fine tune what instances we're on? How do we fine tune configuration? And this starts to leverage the tooling you put in place. So you need that feedback that comes from monitoring and observability tooling to be able to do the performance sort of evaluations. And then lastly, you get into sort of the fancier realm of how do we start blue-greening our deploys? How do we shadow traffic to staging so that we can sort of give developers that opportunity to test their code in staging in an effective way before it goes to production? And it's really about enabling more of that rigor and discipline in the team, right? And oftentimes you need better tooling to be able to do that. The next group that usually gets peeled out from the operations team is at some point you say, we have a lot of security challenges and this is more specialized than our operations team knows how to deal with. So this is when you bring in security teams. And their first level goal is to reduce the surface area of access, right? As a startup, everyone probably has the AWS key, everyone can access the database, everyone can SSH into every machine. And that's fine when it's 5, 10, 20 people. But as you start getting bigger, you start wanting to split that down. Not everyone needs SSH access, not everyone needs to be able to get into the database. And so those are the things you start going for, right? Is those low-hanging fruit. Is reduce the access area to those people who need it, lock down SSH, start looking at using TLS or SSL to protect between different services, start caring about data privacy. So do an audit, understand what's the story of our data in transit, right? As it's going over the network between different services, is it encrypted? As we're storing it in our database or on disk, is it encrypted? And then depending on your business, you might start having to care about compliance, right? So depending on who you sell to, if you're in healthcare or you sell to government or you sell to finance, you might have to care about different compliance laws. And this is where your security teams can be very helpful. And then the last one is the splitting of the development teams themselves. It's sort of the last group to fall. Is at some point, the monolith doesn't scale anymore, right? The app team is too big and you're losing productivity coordinating within the team. And so then at that point it starts making sense to say, okay, can we split this one larger application into sub-applications so that our team size isn't so huge? We don't have 30 people working on one app, right? And the goal is again going back to how do we reduce coordination, right? If we really think about this as a system, the more coordination we have, the less overall throughput we're going to have. So it's important to keep in mind that as we split our monolith and go to these microservices, what we're trading is the complexity on the development side for complexity on the operational side. It's very easy to operate one giant monolith. It's very difficult to operate 500 microservices. So the complexity is going to exist somewhere. You just got to pick where. And so as you make that trade-off, you want to make sure your operations team is mature enough to be able to handle that you've sort of had an opportunity to build those platforms, have that tooling, have the observability. And so that becomes super critical as you make that transition. And the last one is the discipline around the testing and the sort of managing the dependencies between these pieces becomes that much more important. It's a lot easier to do dependency management in a monolith because it's all compiled in. There is no upstream service, right? It compiles as one unit. Versus once you split it, your upstreams are versioned differently than your downstreams. Things are moving at different rates, and so it requires a lot more sort of discipline. So, wrapping it up briefly, the way we like to think about DevOps is it's really a process, right? It's a way that you coordinate the work that's done between your teams, and it's really a focus on agility over risk, right? And what's convenient about that is it aligns with startups, right? Our default mode is failure. We're operating in a high-risk environment. Time to market is important, so agility is our top priority. There is this very natural fit with DevOps. Using things like clouds and modern tools will give you a huge amount of leverage. You don't need to start off with a huge operations team that's racking bare metal and building all this stuff from scratch. You can sort of inherit a lot from clouds and open source. And you really want to avoid building it yourself at almost all costs, right? Especially in the beginning, it's a huge cost center to the business, it's a distraction, and it doesn't add any value to your product. And with that, go forth and build. Thank you very much.